Hi, I'm Emily from emilylearning.com, and in this video, I'll be going through this paper, the iGCSE 2023 Specimen Paper 1 for Chemistry. So let's go through it now. So let's take a look at question 1 first. So in question 1, you are asked which statements about liquids and gases are correct. So let's take a look at them. So 1 cm cube of gas contains more particles than 1 cm cube of liquid. Generally not true. This is because the gas particles, they are found further apart as compared to liquid particles. They are packed more closely together. So there should be more particles in the liquid than gas, all things being equal. So A is wrong. Part B, a given mass of liquid has a fixed volume at room temperature. So this is true. So if you're given a mass of a liquid, if the temperature remains constant, its volume should remain constant. So B is correct and it is the answer. So let's move on to see why C and D are incorrect. Particles in a liquid can easily be forced closer together. No. Okay, you cannot compress a liquid, so they cannot be easily forced closer together because there's still some relatively strong forces of attraction between liquid particles in a liquid. Particles in a liquid have fixed position. This is untrue. This is for particles in a solid. So particles in a solid, they are held in fixed position. So D is also wrong, and the answer for 1 is B. Moving on to question 2, mineral wool soaked in aqueous ammonia is placed in the apparatus shown. After 5 minutes, the damp litmus paper turned blue. So if you have a red litmus paper turned blue, okay, so what it does, it shows that it has detected something that is alkaline. And we know that ammonia is alkaline. So in other words, right, it tells us that the aqueous ammonia, it has vaporized and it has traveled to here and got into contact with the damp red litmus paper to turn it blue. So therefore, what has occurred is diffusion. So it vaporized and it moved here. So initially, there's a higher concentration here. It vaporizes and then it diffuses to an area with a lower concentration, which is at this portion here. So this is diffusion, C. Question 3, which pair of atoms contain the same number of neutrons? So if you are given a nuclide number here, the number on top gives us the nucleon number, which is the number of protons and neutrons. The number at the bottom tells us the number of protons. So to find the number of neutrons, we'll take the top number minus the bottom number. So if I take the top number minus the bottom number, I'll get 32 neutrons from cobalt and 31 neutrons from nickel. So they do not have the same number of neutrons. Okay, doing the same for the rest. So I'll take the top number minus the bottom number to find the number of neutrons. Okay, so basically this is what I get. So B is also wrong. So for C, I'm going to I got 35 and 35. So C is the answer because when I take the nucleon number, which is the number of protons plus neutrons, and it's represented by the number at the top, okay, minus the proton number, which is the number at the bottom. Okay, for C, I got the same number. So this shows that it has the same number of neutrons, sorry. Okay, then for D, it's also not the same. Okay, because this one has 35 neutrons and this one has 36 neutrons. So it's also different. So the answer for 3 is C. Part 4, which statement describes the bonding in sodium chloride? So sodium chloride, it is an ionic compound. So ionic compound, okay, has ionic bonds. So ionic bonds is basically a strong force of attraction between oppositely charged ions, which is B. Moving on to 6, a covalent molecule M contains a total of 4 shared electrons. So what is M? So it has 4 shared electrons. So 4 shared electrons equals to 2 pairs of covalent bonds, right? Or 2 pairs of bonds. So in ammonia, this is how it looks like, NH3. So there are 3 bonds, so there are 6 shared electrons, so it's not ammonia. Hydrogen chloride, it is H is bonded to Cl, there's only 2 shared electrons. For methane, it looks like this. So carbon is bonded to 4 hydrogens. There are 4 single bonds here. So 4 single bonds is a total of 8 shared electrons. So no. For water, you have O bonded to 2H. So each bond is 2 electrons. So total of 4 electrons are involved in the covalent bond. So therefore, the answer for question 5 is D. Next, the lead in a pencil is made up of a mixture of graphite and clay. So when the percentage of graphite is increased, the pencil moves across the paper more easily. Okay, so one thing about graphite, we know that graphite can be used as a lubricant because the layers, so the graphite, the atoms are arranged in hexagonal rings, right? And there's weak forces of attraction between the layers. So it is the graphite that results in the pencil moving across the paper easily because graphite can be used as a lubricant. Okay, so this property, okay, is explained with part C. Graphite is a lubricant, so therefore it allows the pencil to move across the paper easily. Number 7, a compound with the formula XO2 has a relative formula mass of 64. What is X? So we know that the 64 is equals to the relative, the A2 times AR, the relative atomic mass of oxygen, plus the relative atomic mass of X, right? So if you were to go to the periodic table, which is here, okay, and look for oxygen, okay, which is, so it's 16 for oxygen, okay? So now let me go back, okay, to where I was, which is here. Okay, so I know the relative atomic mass of oxygen is 16. So the AR of X is essentially 64 minus 2 of 16, which is 32, which gives me 32. So what is X? So now I need to go back to the periodic table again and look for something that has a relative atomic mass of 32. Okay, so let me do this here. So to look for 32 is germanium. The relative atomic mass is the number at the bottom. So let's look for 32 at the bottom, which is sulfur. So therefore, X is sulfur. So going back to here, I know that because X is 32, from the periodic table, the element that has a relative atomic mass of 32 is sulfur. So therefore, the answer for 7 is D. Moving on to question 8, when lead-2-bromide is electrolyzed using platinum electrolyte, so it is molten. So therefore, the ions present are just lead-2 ions and bromide ions. So the negative electrolyte will attract the positive ions, so you get lead being formed at the negative electrolyte, and the positive electrolyte will attract the negative ions, which is bromide, and then bromide will form bromine, okay, at the positive electrolyte. So lead is a gray liquid, okay, so it's a shiny gray liquid because it is very hot, so lead exists as a liquid, so you get a shiny gray liquid that is formed at the negative electrolyte, so it's either C or D. Next, you have bromine, and because it's very hot, bromine is a gas, and bromine is a brown gas, so therefore the answer for 8 is C. Next, let's look at question 9. Equals nickel sulfate, nickel 2 sulfate, so I know that this is nickel 2 and sulfur is SO4 2 minus, and it is aqueous, so that means that it's water, so therefore I also have H plus and OH minus ions in the solution. It's used as the electrolyte to electroplate a piece of steel with nickel. So which material are used as the negative electrolyte and positive electrolyte? So this one is known as electroplating. So in electroplating, what do? Well, one of them will dissolve, right? So we want to electroplate a piece of steel with nickel. So the nickel must dissolve. So if you want something to dissolve, you need to place it at the anode, and the anode is the positively charged electrode or the positive electrode. And the cathode is where you place the item to be electroplated. So metal will be discharged at the cathode. Okay, so anode dissolve, cathode discharge. You get the metal. So the cathode is where you place the steel. Okay, and the cathode is negatively charged. So the negative one is the steel, and the positive one is the nickel. So for question 9, the answer is D. Question 10. Which row shows the waste products released from the exhaust of a vehicle powered using a hydrogen-oxygen fuel cell? So if you have a hydrogen-oxygen fuel cell, okay, so they are asking for what are the waste products released, right? So for the hydrogen-oxygen nuclear cell, it's very clean, okay, because your hydrogen and oxygen, they will form water, okay? You're not burning any hydrocarbons. Okay, so therefore you do not have carbon dioxide or oxides of nitrogen being formed. You only have water as the only product. So therefore it is D. The answer is D, because water is the only product from the hydrogen oxygen fuel cell. Question 11. So this is the reaction pathway of a diagram. So this is the reactants and this is the products. The products is at a higher energy level than the reactants. So when the energy level increase, this is delta H is positive, and it is an endothermic reaction. Okay, and if it is an endothermic reaction, heat is absorbed. Okay, and the temperature decreases because you absorb heat from the surrounding, so there's, you can think of it, less heat in the surrounding, so temperature decreases. Okay, so based on all that we have written here, only C is correct. So 11 is C. Next, which of the changes are physical change? So physical change are your changes in state and your separation. Okay, physical separation, like your distillation, fractional distillation, and also your dissolving something in another thing. So melting ice to form water. So ice is basically H2O in solid form. Water is basically H2O in liquid form. Water remains as water. This is a physical change. Burning hydrogen to form water. So H2 plus O2, you form H2O. So this is not a physical change. This is a chemical change because your hydrogen and your oxygen form a different compound, which is water. So this is a chemical change. Adding sodium to water. So you have learned in the group 1 chapter, when you add sodium to water, you get sodium hydroxide and hydrogen gas, right? So because you get different your reactants get converted into other products, so therefore this is a physical change. This is no longer a physical change, it is a chemical change. So adding to sodium to water is a reaction, so it's not a physical change. Next, boiling water to form steam. So when you boil water to form steam, the water changes from liquid state to gaseous state, but it is still H2O. So this is a physical change. So basically phase change, like your melting, boiling, condensation, evaporation, and freezing, they are all physical changes. So 1 and 4 are physical change. So the answer for 12 is B. Moving on to question 13, the diagram shows an experiment to measure the rate of a chemical reaction. So what changes increases the rate of reaction? So basically we're adding metal to dilute acid. Okay, and then we are going to measure the volume of hydrogen that is being produced, okay, at different time intervals to check what is the rate. Okay, so how do you increase the rate of the reaction? So to increase the rate of the reactions, there are some things that we can do, right? We can increase the size of we can increase the surface area by making the metal into smaller pieces. So yes, we can use powdered metal. Okay, using more concentrated acid, you can increase the concentration of the acid, this will also increase the rate of the reaction. Heating, so when you increase the temperature, you will increase the rate of reaction. So all these three will increase rate of reaction. Now, if I were to add the water to the flask, okay, they are not very sure what they refer to the flask, so it may probably is this one. So if I add water to this flask here, I will be diluting any acid that comes in. So when you dilute something, you decrease the rate of the reaction. So therefore, A is the answer. A will decrease the rate of the reaction. Moving on to question 14, which row correctly matches the experiments and observations to the identity of the underlying substance? So let's take a look at this. Blue crystals are heated, the crystals turn white and steam is given out. So basically the hydrated crystals turned into anhydrous one. So the blue one is the hydrated cobalt 2 chloride. Okay. Then turned white and steam is given out. So blue is hydrated, okay, but it turns white, right? So if it turns white, it is not cobalt 2. So for hydrated cobalt 2 chloride, right, it starts off with blue. When it becomes anhydrous, it is pink. If you have copper 2 sulfate, I'll write it as SO4. So if it's hydrated, it is blue. If it's anhydrous, it is white. So if you have blue and white, probably we are looking at copper 2 sulfate. So A is wrong. Pink crystals are heated, turns blue, no, because you always started off with the hydrated one. So this one is out already. Water is added to the blue solid. So the blue solid turns pink, no. So if you add water to the pink solid, it will turn blue. Okay, but then if it is already hydrated, you add water, it is still hydrated. So no. Okay. Next, water is added to a white solid. The white solid is turned blue. So when you add water to an anhydrous one, okay, which is probably copper 2 sulfate, it turns blue. So it is correct. So D is the answer. Okay, so you add water to the anhydrous one, then it will become hydrated. If you add water to the hydrated one, it remains. So like for example for C, if it's a blue solid and it is copper 2 sulfate, right? If you add water to it, it will remain blue. Okay, because it's already hydrated, adding water just keeps it hydrated. Okay, now let's move on to 15. Which of the reactions shows an oxidation reaction? So one look, we know A is definitely an oxidation reaction. So combustion is always an oxidation reaction. Or you can look at it as carbon gains oxygen to form carbon dioxide. There's an increase in oxygen. So therefore, this is an oxidation reaction. Okay. Then the rest are not oxidation reactions. Let's go on to 16. Farmers spread calcium hydroxide on their fields to neutralize soils that are too acidic for crops to grow well. So which ion neutralizes the acid in the soil? So acids H+ are neutralized by hydroxide ions, which is OH-. Okay, so it is D. Okay, because the hydroxide ions give OH-. So and OH- can react with H+. So therefore, the one that neutralizes the acid is OH-. So for question 16 is D. Next, which of the following are acidic? So you have 4 different solutions. They are tested with the universal indicator. So for universal indicator, when the color is red and orange, it is acidic. For purple, it is alkaline. For green, it is neutral. So K and M are acidic. So the answer is B. Next, so this is period 3 of the periodic table. What increases from Na to Ar in period 3? So density decreases. So you can look at it as this is a solid. All these are solids. Okay, then these are gases. Then you have solids in between. Okay, so the density actually increase and decreases. So no, it doesn't increase. Melting point, no. Those here have a higher melting point than those on the right. So melting point doesn't increase. But yes, the non-metallic character increases as you move from left to right. Okay, so the answer is C. Next, the number of electron shells does not increase because they are in the same period. The number of shells are the same. So because this is period 3, all of their atoms have 3 shells of electrons, 3 shells filled with electrons. All right, so the answer for 18 is C. Moving on to 19, sodium and rubidium are in group 1 of the periodic table, and we know that sodium is above rubidium in the periodic table. And we know that for group 1, okay, the reactivity increases when you go down the periodic table. So next, let's look at what are the answer options, and you're asked to select which one is correct. Sodium atoms have more electrons than rubidium atoms. No. If you look at the periodic table, okay, rubidium has more electrons. So the more protons they have, which is represented by the atomic number, the more electrons they have. Rubidium has more protons than has more protons than sodium. In other words, rubidium has more electrons than sodium. Sodium has a lower density than rubidium. This is not sodium has a lower density than rubidium. This is true. So for your group 1 metals, right, as you go down, the density increases. So in other words, rubidium has a higher density than sodium. So B is correct. Sodium has a lower melting point than rubidium. This is not true. As you go down, your melting point decreases. So D, sodium is more reactive than rubidium. This is not true. Rubidium is more reactive than sodium. So for this question here, it actually tests you on your knowledge of the trends, okay, as you go down group 1. Next, let's look at group 7. Chlorine, bromine, and iodine are elements in group 7 of the periodic table. Which one about these elements is correct? So the color gets lighter down the group. No. The color intensity increases down the group. So chlorine is above bromine. Bromine is above iodine. So chlorine gas is yellowish green. Bromine gas is reddish brown. Iodine is black. So this color intensity is the highest. So as you go down the group, the color intensity increases. Density decreases down the group. This is also not true. Density increases down the group. So you can look at it in terms of the state. So this is a gas. Chlorine is a gas. Bromine is a liquid. Iodine is a solid. Solid has a higher density compared to liquid. Liquid has a higher density compared to gas. So therefore, the density increases down the group. So B is also wrong. They are all gases at room temperature and pressure. Wrong. This is a gas. This is a liquid. This is a solid at room temperature. They are all non-metals. This is true. So D is correct. Next, 21, which row describe the properties of a typical transition elements? So transition elements, they have high melting point, they form colored compounds, and they act as catalysts. So it's high, yes, yes. So the answer is B. Next, which statement about noble gas is correct? So noble gas, they do not exist as diatomic molecules, they exist as atoms. Okay, only by themselves because they already have a stable electronic configuration, so they do not want to form bonds with any other atoms. Noble gas are not reactive because they are already very stable. So very stable means they don't want to react because they want to keep their stable electronic configuration. Noble gases, they have a full outer electron shell. This is true, and this is why they are so stable and unreactive. Noble gas are found on the left hand side of the periodic table. Wrong. They are found on the right hand side of the periodic table, as can be seen from here. Okay, they are way on the right. All the way on the right. This is your noble gas. Oops. Now going on to question 23. What is the property of all metals? So all metals conduct electricity. This is true. All metals are hard. Not necessary. Mercury is a liquid, so it can be hard. There are some metals with low melting point. This is true. Like for example, your sodium, group 1 metals, they have a relatively low melting point compared to the metals in other groups. So this one might not be true. All metals react with water. This is not true. Only metals above hydrogen in the reactivity series will react with water. So A is the correct answer. Next question 24. Which statement explains why aluminium is used in the manufacture of aircraft? So the reason why aluminium is used is because it has a low density. Okay, it is light. Okay, nothing to do with whether it heats well or is a good insulator. In fact, it's a good conductor of heat, it's a good heat insulator. Moving on to question 25, so which they ask which one represents a solid alloy. So we see two things, one of it is solid, one of it is alloy. So when we see the word solid and alloy, okay, so it's either A, B, and C because we want solids. C is out because an alloy is a mixture of metal. Okay, so we want a mixture of metal. C only has one type, atoms of one type of element, so C is not an alloy because there's no mixture. So it's either A or B. So why do we have alloys? We want to put in an atom that is of a different size from the metal to disrupt the regular pattern so that the layers of atoms don't slide past each other easily. If you take a look at this, they are all the same size. So A is out. So the answer is B, okay, because the added substance must have a different size from the rest of the atoms so as to disrupt the orderly arrangement of these layers of atoms so that it is not so easy for the layers of atoms to slide past each other. So therefore the answer for 25 is B. Moving on to question 26. Metals W, X, Y, and Z are reacted with dilute acid. The oxides of metal W, X, Y, and Z are heated with carbon. So the results are shown. So you ask which one is what is the order of reactivity. So we know that the more readily it reacts with acid, the more reactive it is. The more readily it can be reduced, its oxide can be reduced by heating with carbon, the less reactive it is. So in other words, right, if we look at this, Z is the least reactive because this one tests for reactivity. More reactive, then it will undergo this reaction. So Z is the least reactive because it doesn't react with acid. So the least reactive is Z. So I have either A and B as the answer. I can eliminate C and D now. You look at this, W and X are fizzling, but Y is violent. So Y is the most reactive. So, okay, A and B all have Y as the most reactive. So now we are left with the order of W and X, right? So we know that the less reactive the metal is, the more readily its metal oxide gets reduced when heated with carbon, right? So if we look at this, so X undergoes this reaction, but not W. So in other words, right, X is less reactive than W. Okay, we don't need to consider the rest. Okay, Y, which is the most reactive, there's no reaction because this reaction is for the less reactive metals. The less reactive the metal, the more readily the metal oxide gets reduced. Okay, so from here we know that from these results we know that X is less reactive than W. So X is less reactive than W, so the answer for 26 is A. Moving on to question 27. So the diagram shows experiment involving the rusting of iron. So in order for rusting to take place, what do we need? We need air. Okay, in particular, we need oxygen. And we also need water. Okay, and we need iron, of course. So all of them have iron nails. So yeah, rusting. So you have the iron component. So let's take a look at this. A student predicted the results. Okay, so it says that in P, the iron nails will rust. So in test tube P, there is air. And there's also water, so yes, I agree, there's rusting. In test tube Q, there's oil, which will prevent the air from entering. But there's also water that is used to remove air, that's boiled to remove air. So in other words, we have water, but we do not have air, so it can't rust. Okay, so yes, test tube Q, it doesn't rust, I agree as well. Now let's move on to the next one. So in test tube R, you have anhydrous calcium chloride. So the purpose of calcium chloride is to take away the water. So there's no water. Okay, but there is air. So you have air but no water, it also can't rust. So Q and R, it does not rust. So I agree with all the statements that was made. So therefore the answer is A. Moving on to question 28, which statement about the extraction of iron in the blast furnace is correct? So this one is basically testing you on your knowledge of the blast furnace. So let's take a look at this. So calcium oxide reacts with basic impurities. Calcium oxide is already basic itself. It doesn't react with the basic impurities. In fact, it reacts with silicon dioxide, which is an acidic impurity. So this is wrong. Next, carbon is burned to provide heat. Yes, true, because the burning of carbon or combustion is exothermic. It provides heat for the reaction. Iron 3 is reduced to iron by carbon dioxide. No, iron 3 oxide is reduced to iron by carbon monoxide. Okay, so C is not correct. D, the raw materials are bauxite, limestone, and coke. Okay, no. So bauxite is the ore of aluminium, not iron. So therefore, this is incorrect. Okay. So the answer for 28 is B. 29, which process is used to convert calcium carbonate into calcium oxide? Basically, you're going to heat it until it decomposes to form calcium oxide and carbon dioxide, and this is called thermal decomposition. Question 30, which substance is beneficial to aquatic life? So aquatic life, they need dissolved oxygen to breathe. So A. Phosphates are needed for plant growth. Okay. Plastics is bad. Sewage, we also know, is bad for aquatic life. Alright. It pollutes the water and make it difficult for the plants and animals inside the water to survive. Okay. Moving on to question 31. A new planet has been discovered and its atmosphere has been analyzed. Okay, so we know that there's 4% carbon dioxide, 72% nitrogen, 24% oxygen, which gas are present in the atmosphere of the planet in a higher percentage than they are in the Earth's atmosphere. So on Earth, okay, we have less than 1% carbon dioxide, okay, and we have around 20% that is oxygen, and around 79% is nitrogen. So the one that is in higher percentage is oxygen and carbon dioxide, which is A. Question 32, which statement is correct? Atmospheric carbon dioxide is not a cause of climate change. No, if you have too much carbon dioxide, it results in global warming because carbon dioxide is a greenhouse gas. It can absorb heat, so it makes the earth warmer. So this is not correct. Atmospheric carbon monoxide is produced by complete combustion of carbon-containing fuels. No, atmospheric carbon monoxide is produced by incomplete combustion. If you have complete combustion of carbon-containing fuels, you get carbon dioxide. If you have incomplete combustion because there's insufficient air, you get carbon monoxide. So 32 is also wrong. Burning natural gas decreases the level of carbon dioxide in the air. No, when you burn natural gas, which is essentially methane, okay, you will form CO2 and H2O. Okay, and this will increase the amount of carbon dioxide in the air. So this is also not correct. Decomposition of vegetation causes an increase in atmospheric methane. This is correct. When we decompose vegetation, it produces greenhouse gas such as methane, which will, so this is true. So decomposition will produce methane. So D is true. So the answer for 32 is D. Question 33, plastic combusts to form sulfur dioxide and hydrogen chloride. So how could both gases be removed from the air? So sulfur dioxide is an acidic gas. So to remove it, you need to pass it over something that is alkaline. Same thing, hydrogen chloride is acidic. So in order to remove SO2 and HCl, you will add something that is alkaline. So cobalt 2 chloride is a salt, it is not alkaline. So you will pass it over calcium oxide. So being calcium oxide is a base, so it can react with acidic oxides as well as hydrogen chloride to form salt, hence removing them from the air. So the answer for 33 is B. So for C and D, the catalytic converter, they do not have any effect on sulfur dioxide or hydrogen chloride. They are only help to remove CO, unburnt hydrocarbons, and also your oxides of nitrogen. Okay, no impact on sulfur dioxide and hydrogen chloride. So you need to remove them by reacting with something alkaline. Pass the gases through filter paper. They are all gases. They will pass through the filter paper. Okay, so no. Next, going on to question 34, limestone fizzes and dissolves in hydrochloric acid. Limestone is basically calcium carbonate. So what is the word equation for this reaction? So calcium carbonate, being a carbonate, it will react with hydrochloric acid. So carbonate plus acid, it will form salt, water, and carbon dioxide. And the salt is calcium chloride. Okay, so it is calcium carbonate plus hydrochloric acid. You get a salt, which is calcium chloride plus water plus carbon dioxide. So the answer is B. Moving on to question 35, 3 equations involving organic compounds are shown. How many different homologous series are shown in the equation? Okay, so let's look at this. C4H10, this is an alkane because it follows CnH2n plus 2. So this is an alkane. Let me call an alkane A1. Okay, CnH2n is an alkene. Let me call an alkene A2. Alright, so this is A1. This is A2. C2H4 follows CnH2n, so it's an alkene. Then C2H4, okay, it follows the alkane general formula. So I have two different types of homologous series in the first equation, alkanes and alkenes. Second one, C2H4 is an alkene. Water is not an organic compound. Next, C2H5OH is an alcohol. So now I have three different types of homologous series, alkane, alkene, and alcohol. This again is an alcohol. Then oxygen is not an organic compound, neither is carbon dioxide or water. So in all, I have three different homologous series, and the answer is C. And the three homologous series are basically your alkane, alkene, and alcohol. Moving on to question 36, petroleum is a mixture of different hydrocarbons. Which process is used to separate petroleum into groups of similar hydrocarbons? Basically, it's fractional distillation. So they are separated based on their boiling point. So therefore, fractional distillation is used. Question 37, ethene is a hydrocarbon. So which row shows the type of covalent bonds between the carbon atoms in ethene and the effect of ethene on aqueous bromine? So we know that in ethene, it is an alkene, and this is how it looks like, right? So it has a CC double bond. Okay, so between the carbon atoms, it is a double bond. So it's either C or D, A and B are out. So when you add bromine, aqueous bromine to an alkene, what happens is aqueous bromine turns from brown to colorless. So the answer is C. Moving on to question 38, which statement about ethanoic acid are correct? So ethanoic acid is an acid, so it's acidic, so it doesn't turn universal indicator purple. Purple is for alkaline. Okay, it turns it red, orange because it is acidic. It reacts with magnesium to form hydrogen gas. Yes, magnesium is above hydrogen in the reactivity series. So this metal can react with acid to give hydrogen gas. So this is correct. It reacts with calcium carbonate to form carbon dioxide gas. So ethanoic acid is an acid. So acid can undergo reactions with metals that are above hydrogen in the reactivity series. React with carbonates to form carbon dioxide and water. So 3 is also correct. Okay, and let's look at 4. It decolorizes aqueous bromine. It is not true because it doesn't have a CC double bond. So D4 is wrong. Okay, only alkenes, okay, or compounds with CC double bonds or CC triple bonds can decolorize bromine in the dark. So 4 is wrong. So the answer is 2 and 3 only for 38, which is D. Question 39, 5 steps in an acid-base titration. So what do you do in a titration? So let's read the steps first. You slowly add the acid from the burette into a conical flask until the indicator becomes colorless. So before you add it, you need the indicator, right? So this step 2 must go before step 1. So we know 2 goes before 1 already. So this is adding indicator with the thymophthalate, which is an indicator. So you need to add before you add the acid dropwise, right? So what do you do first? So we use a volumetric pipette to add a volume of alkali to the conical flask. This should even go before you add the indicator. Okay, so you first add the alkali into the conical flask. This is 3. Then 2, you add indicator. Okay. Okay, so after you add, right, the alkali and add the indicator, okay, so we know that 3 and 2 must come before 1. So I can first eliminate A, because 3 and 2, 3 first followed by 2 then 1. So 3 must be here, here and here. So B is a possibility. 3 followed by somewhere you have 2, so C is also out. 3, okay. In fact, without doing anything, the answer is B. So I know that 3 must go first. So I must first put alkali into a conical flask before I add the indicator with its thymophytylene. Then followed by, okay, adding the acid from the burette, right? So I know somewhere it must go 3, 2, and then 1. Then I have 4 and 5. So I know that finally I will record the final volume of acid in the burette. This will be 5, should be the last step. So I can read the initial volume. Usually after I put in the indicator, then I will start reading what is the volume in the initial volume. Okay, or I can also, so I can do it here. But actually, whether you put 4 here or here is okay. Okay, you just need to read the volume before you add in any of the acid, and you need to record it when you finished it. So the answer is 32415, which is B for question 39. And in fact, once you know 1, 2, and 3, the order of 1, 2, and 3, which is 3, 2, and 1, you can just, and we know that 5 is definitely the last step. We have eliminated all the options and gotten B. Now let's look at question 14, which is a chromatogram. So the chromatogram obtained from 4 mixtures of dyes P, Q, R, and S is shown. What is the total number of different dyes in the 4 mixture? So how many dyes are there? So let's count that. 1 type of dye, 2, 3, 4, 5. So there are a total of 5 different dyes, okay, from this chromatogram. Okay, because each spot represents one substance. So there are a total of 5 of them. So the answer is C.